So given that the point A has position vector 3i minus 7j and the point B has position vector 8i plus 3j, find the vector from A to B. So that's what it symbolizes as, A to B. So what I did here, I just said, okay, let's call this vector here little a and this one little b, just to give it a name. And now the definition of A to B is literally like this. So from this coordinate A and this coordinate B, we have some given position, which I called little a and little b. Now from finding A to B, you just have to find pretty much B minus A in simple terms, yeah, B minus A. And what I do is I always convert these into columns. So 8i plus 3j can be written as 8 and 3, where top is x and bottom is y, or I and j, minus the a, which is 3i and 7 minus 7j, so 3 and minus 7 for the i's and j's. And that's it. Now we just subtract. So 8 take away 3 is 5, and 3 minus 7 is 10. So the position vector, or the directional vector is the correct term. The directional vector is 5, 10. Easy. Now B, find the magnitude of this vector. So the bars always means magnitude, yeah? That literally is telling us to use Pythagoras' theorem to solve it. Or to make your life easy, we can say, okay, the general formula is simply the distance formula. So it would literally be 5 squared plus 10 squared. So essentially essentially the distance formula or Pythagoras. Yeah. Now giving us a simplified third, well, just put that in your calculator. And when I did that, I got 5 root 5. So let me write down 5 root 5. That's it. Easy stuff. So yeah, guys, I want to say, if you guys are finding these videos helpful, just give me a like and yeah, share this to your friends and subscribe even. Okay, guys, number 4. Let's check it out. So here we're given a cubic equation as a function. So we know it's cubic because it begins with an x cubed term. Now the question tells us that we need to use the factor theorem to show that x minus 3 is a factor of fx. So yeah, so essentially to show something is a factor, you just have to plug in the value of x equals 3 into this equation. And when you do that, and if your function at x equals 3 equals 0, then we can say that yes, this term is a factor. So really, we just want to prove that we get 0 remainders. So when we factorize this, you can factorize it no problem. That's really it. But anyway, when you do plug in x equals 3, you do indeed get 0. So remember, it will be 4 times 3 cubed minus 12 times 3 squared plus 2 times 3 minus 6. In your working out, always write it like this. So say, okay, f3 equals 4 times 3 cubed minus 12 times 3 squared plus 2 times 3 minus 6. And then say this equals 0 and then make a statement. Say yes, x minus 3 is a factor of fx. It is a factor of the function, literally. That's it. Now part B. Hence show that 3, in other words x equals 3, is the only root of the equation when the function is set to 0. Okay, so to prove this, we need to use long division now, because we want to show that when we divide this, we can get firstly a quadratic equation, and then we need to show that we cannot factorize a quadratic equation, because that's the only way to show that we have one solution, which is 3, x minus 3 that is. Anyway, let's go ahead and do some long division, see what we get. So first things first, to start this, we will ask ourselves, how many times does x go into 4x cubed? Well, it goes exactly 4x squared times, because 4x squared times x gives us 4x cubed. Now all we do is just multiply this out. So let's do this. So 4x squared times x minus 3 will give us 4x cubed minus 12x squared. So that's good so far. So weirdly enough, you actually get the same result. Now subtracting this, you get 0, which is actually again very weird. Now we drop this down and we should get plus 2x here. And now we put the 0. Now we ask ourselves, how many times does x go into 0? Well, this would be 0, so we have to put a 0 term here. So now we say, okay, 0 times the x minus 3 term will give us 0 plus 0. Wow. I'm not really used to this kind of long division. It's usually a lot more intense. Now we subtract this and you're left with 2x. Drop the minus 6 down. So you got 2x minus 6. Now once again, we ask ourselves, how many times does x go into 2x? Well, it goes exactly twice. Times in this, you get 2 times x minus 3, you get 2x minus 6. And yes, subtracting this, you get no remainder. So actually, even though this look weird, this is actually correct. Now what do we have so far? So now we got 4x squared plus 2 as our final quotient. This is our solved solution. So we can say that this term here times x minus 3 will give us the fx function. Okay, so we can say therefore, so just summarizing this, the function can be factorized to x minus 3 and 4x squared plus 2. Now at this stage we cannot actually solve this any further. You can take the 2 out of this, so if I just bring it to the front line, we're going to have x minus 3 and we're going to have now 2x squared plus 1. You can, at this stage you cannot factorize this one because this one you can't really do much. If you set this one to 0, for example, just to prove that you can't factorize it, if you move minus 1 across, you're going to get 2x squared equals negative 1 divided by 2, and that's the problem. You cannot square root negative number, so in this case you cannot get a solution. So that's it. So that therefore we can pretty much say that x minus 3 is the only solution, because when you set this to 0 you can get a solution, which is only x equals 3. That's it. That's really how you solve this kind of problem. But yeah, if you guys so far have enjoyed these videos, you know, please give me a like and tell your friends about it, and of course subscribe, you know, as always, and make sure you leave a comment below if you're unsure about anything. You know, I'm here to help as always. But yeah, thanks for watching guys, and see you next time. Ciao.